In this video, we're going to focus on three models of addition, and we'll do so in Base 10. These models of addition illustrate the transition that teachers and students make going from concrete models to abstract algorithms for addition. The problem we're going to focus on is 174 plus 248. To start off, model number 1 is a concrete model of addition using Base 10 blocks. And to illustrate this, I'm going to go to a website. It's an app, and it looks like this. The address is up above. It's also posted in the course. And I already have the numbers laid out. I've got 100, which is 1 flat, 7 longs, and 4 ones. And number 2, the second number, 200, so 2 flats, 40, so 4 longs, and 8 ones. Now, the operation of addition, as it is with the initial, some of the more elementary set model, is you put the objects together. So we put these objects together, and what we end up having, and so we can join them together a little bit if we like. So move them closer together. Hold on, let me get there it is. So I can move them closer together like this, if you like. And so that means when I put the two numbers together, when I join them, in other words, 174 and 248, and I'll just grab all these at once. There we go. What you have is you've got 12 ones, you've got 7 and 4, 11 tens or longs, and you've got 3 flats or hundreds. Now, what you want to do, and this is the key with place value, is we always trade up. So if we have 10 units, that equals 1 long. So I'm going to grab 10 units. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are my 10 units. And what I'm going to do is I'm going to trade those for 1 long. So I'm going to delete those, or put them off to the side, we'll say. They still exist, they're just getting traded, so they're off to the side. And we're going to trade those for 1 long. And I'll put that long right here. Now, if it's nice to keep track of this, we can make that a different color. So that's the one we've traded. So we're left with just 2 units. Now, let's do another trade. We know that 10 longs equal 1 flat. So if I take 10 of these longs, so 1, 2, 3, 4, 5, we include the one we traded, so we'll trade that one back. 6, 7, 8, 9, 10, that would be these 10 longs right there. Okay? So those are 10 longs. They can be traded for 1 flat. So what I'll do the same thing. I'll move those off to the side like that. So there we go. Remember, they've been traded, and they're traded for 1 flat. So let's grab 1 flat, and that's one we traded, and we'll make that one red. There you go. So after doing all of my trades, what I'm left with is 4 flats or 400s, 2 longs, which is essentially 20, and 2 ones, which is 2. So we have to sort of remember the expanded model of addition. What we'd say at the end is that 174, I'll write it on this page, 174 plus 248, all in Base 10. And what does that equal? Let's go back to the image. 400s and 2 tens and 2. So I like to write that in expanded form, so that we have 4 100s or 4 flats plus 2 tens plus 2 units or ones. So in using concrete models, 422. Now, from there, from a concrete model, it's often helpful to go through an intermediate algorithm. Now, there are a couple intermediate algorithms. They vary in terms of what they represent, but all in all, what they're trying to represent is the actions that you did with these concrete objects. So what you do for one version, and so the version I'll ask you to use in the class, is we're going to add our ones first of all. And we're going to keep track. Remember the columns, and this is important. The kids will know that this is the ones column. This is the tens column, and this is the hundreds column. So again, keep in mind, this is not a model for second graders or first graders necessarily. This is a model when students start to use multi-digits and place value. So what we'll do is we'll just focus on the ones first for the intermediate algorithm. Now again, this is an intermediate algorithm. There are others as well. But this is the one I'll ask you to know. So let's look at the ones. For the ones, we've got 4 plus 8. And again, the kids that will be doing this will know 4 plus 8 is 12. And 12 is 1 10 and 2 ones. Okay, so 4 plus 8 is equal to 110. So that's 110 plus 2 ones. Secondly, let's focus on the tens. We've got 7 tens and 4 tens. And again, the kids will know that that is 70 plus 40. And one of the earliest things that you do in elementary school is skip counting by tens, for example. And you get the whole class to say 10, 20, 30, 40. So 70 plus 40 is equal to 110. So that would be 100 plus 10, or 110. So I will write that 70 plus 40, 110. So what you're doing is you're representing the sum of the ones on this line, the first line, the sum of the tens on the second line, and then we'll look at the sum of the hundreds. Notice there's no carrying in this algorithm. We're going to focus on that in just a bit. So 100 plus 200, again, this is for kids who are able, so we can count by hundreds, skip counting by hundreds. 100 plus 200 is 3 hundreds. And then to find the sum, all you need to do is add those up. So 2 plus 0 plus 0, that is 2 ones. 2 plus 2 is 2, so that's 2 tens. 3 plus 1, 1 plus 3 is 4 100s. So, as it was in the first case, 174 plus 248 is equal to 422. And that is the intermediate algorithm, where you represent the ones, the tens, and the hundreds in separate lines, and then add them up. Okay? It's very similar to mental math. Lastly, we'll focus on the standard algorithm. And again, what I want to do is, I know that you all know the standard algorithm. I just want to connect it to these sort of intermediate steps. Notice what I've done here is 4 plus 8 we said was 12. That was 2 ones and 1 10. Now, there's nothing that said we had the right to 10 down below. We could have written the 10 up above. And that is all a standard algorithm is doing. So you'll say for the standard algorithm, 4 plus 8 is 12. That is 2 ones and 1 10. So again, connect it to the intermediate algorithm. That's the idea. The intermediate algorithm is a step towards this the more standard algorithm. Then you say, okay, I've got 11. 7 plus 4 is 11. Okay, which is 11 tens. But you also have this additional 10, which is carried. So that'd be 12 tens. 12 tens is equal to 1 100. So 12 tens, 12 tens is 120, which is 1 100 plus 2 tens. So 1 plus 7 plus 4 is 2 tens and 1/100. Again, look at what happened with the standard algorithm, the intermediate algorithm. That 1/100 was on the intermediate algorithm was written right here. All we're doing with the standard algorithm is recording it up above. All right, so the intermediate algorithm is a transition to the standard algorithm. Lastly, 1 plus 1 plus 2 gives me, and I'll do it in the same color. Hold on, I think it's black is what I'm doing it in, is 4/100s, and we still have 422. So the idea is the models of addition help students make the transition. This is what I want you to understand. You transition from concrete models to an intermediate algorithm to the standard algorithm.